Okay, hello class. Hope you had a great first week of online learning with science, and now we're going to move on to week 2. We're going to continue on with our discussion of volcanoes. Last week we talked about different types of volcanoes, and this week we're going to talk about what causes volcanoes to erupt. In addition to that, what causes earthquakes to happen. In order to understand what causes earthquakes and volcanoes, we need to understand these 6 bullet points here. You need to understand what continental drift is, what seafloor spreading is, what are plate tectonics, what is the ring of fire, what are the different types of boundaries, and the Richter scale. So let's go ahead and start with continental drift. Continental drift has to do with the concept that the continents at one point were in a different location, and they have since spread to their current locations. We have talked about that in class with this picture here, this concept of Pangea. So let's read what this slide says. It says, according to this concept, Earth's continents have slowly drifted by moving through the ocean floor. So in other words, they are at a different spot than where they originally were. They have moved over time. We can see that at one point, according to this concept of Pangea, some people believe that at one time all of the continents were joined in a single land mass that we call Pangea. You can see in the picture here that we have like the light blue continent of Africa with right next to the dark blue continent of South America. There's India and Antarctica, and all the continents are squished together to form more of a single land mass that was all right next to each other. So there's different evidence for this. There's 3 points here on this slide. The first evidence is the outline of the continents. As we can see, a lot of those continents fit together almost like a puzzle piece. You can see specifically where South America and Africa fit together really, really well. It almost looks like it is a puzzle. You can see that India and Antarctica and North America, that they can also fit together in a really kind of oddly similar shape. We also find that there are identical fossils of the same animals found in Africa and South America, which is interesting because obviously currently there are different animals in Africa and South America, and so the fact that they were able to find these fossils that were the same, from the exact same species of animals on 2 separate continents that are thousands of miles apart is really interesting. And also the rock beds. In other words, when you dig deep down into the earth, you find a lot of rock. And on each continent, most of the time you suspect to find different ones. But in South America and Africa, they are very, very similar, which also leads people to believe that at one point, these continents might have actually been really, really close together. Seafloor spreading. Seafloor spreading is kind of what it sounds like. The seafloor is spreading or moving around. You can think about if you have some toast and you were to throw some peanut butter on that toast, you'd have to spread it around and make it cover more space. It's kind of the same idea with the ocean floor. Let's read what it says and then let's talk about the pictures. It says spreading center on the ocean floor where lava erupts out of. This produces new ocean crust. So I want you to look at the first picture, the more cartoony one that doesn't have any words on it. You can see here, that's the ocean, obviously. And then below it, we have the Earth's crust. And you can see the bottom red, that is where the magma is. Similar to like a volcano, that would be like the magma chamber. Imagine that there is a portion of the Earth's crust that's deep down under the ocean that's actually open with like holes and cracks, and lava rises up out of it. And once it comes out and it's in the ocean, it obviously cools rapidly and turns into rock. And then that pushes the seafloor that it is on top of out of the way, and thus making the ocean floor spread and become bigger. So it says seafloor spreading is the process of forming new ocean crust. This process can explain how continents moved. So again, the lava comes up out of the earth. As it cools, it kind of pushes the old crust out of the way, and it moves, it causes movement, and then we have new ocean crust. And then the same thing is shown in this other picture with the words. This is actually from your book. I took a picture of it. It shows the exact same thing. The magma below the earth in the lithosphere coming out into the earth's crust in the ocean, and then forming new ocean floor. Okay, now we're going to talk about plate tectonics. Plate tectonics is a theory. A lot of you probably remember writing this vocabulary word down because it was hard to find in the book, but it is a theory that states that Earth's lithosphere, and I'm going to go back here so you can see this diagram from page 271 in your book. The lithosphere is the layer of the Earth that is right below the ocean crust. So it is a layer of the Earth. So this lithosphere here, they're saying that lithosphere is actually broken into large slabs of rock. It is not solid. It's almost like a jigsaw puzzle in that they're all connected, but they are not physically attached to one another. They are just kind of next to one another. These slabs are called tectonic plates, and these plates have the ability to move around, or they're kind of floating, and as they float, obviously movement happens, and they can shift places. And it says that the plates move slowly around the Earth's surface. So you see in this picture here, which again I took from your book, each of these different plates have different names. So you can see the Eurasia plate, which is underneath Europe and Asia. We have the African plate, which is pretty much just the continent of Africa and then a lot of ocean. And then we have the North American plate, the South American plate, there's a Pacific plate, an Antarctic plate, and the Indo-Australian plate. So all of these plates are, again, they're not actually connected, they're just next to each other. So this might be a new concept for some of you. A lot of people don't realize that what we actually are standing on when we're standing on the Earth's crust are pieces of Earth that are moving. They're not all one connected piece, but they are puzzle pieces, just like these blue lines show, where they're touching, but they're not attached. So what causes a volcano to form? Volcanoes are formed when magma that's inside the Earth's upper mantle works its way to the surface. Once it reaches the surface, it erupts to form lava and ash deposits. Over time, as the volcano continues to erupt, it will get bigger and bigger. So imagine this volcanic lava and ash is coming up out of the volcano. It spews up and then it lands on the sides of the volcano. Once it cools, it obviously has left more rock and more landform. And as that happens over and over and over again, the volcano gets bigger. So I think this is a video for us to watch. It's just a short little illustration.
Cinder cones consist of pyroclastic material that has settled out in a cone near a volcanic vent. A cinder cone is built as pyroclasts are ejected into the atmosphere. The larger, heavier pyroclasts settle close to the vent, and the smaller, lighter material settles farther away. Lava flows are also associated with cinder cones. The lava is too heavy to flow over the top of the growing cinder cone. Instead, it flows beneath it, pushing the pyroclasts out of the way. The pyroclasts accumulate around the vent and settle at the angle of repose, forming a cinder cone. Much of the original lava flow is buried by the pyroclasts.
A lot of baby and toddler toys are pretty much junk.
Okay, so you can see from that video that as the lava and the ash is coming up out of the volcano, it lands on the sides, it dries, and then makes the volcano or the mountain place where the volcano is larger. And then this happens over and over and over again until the volcano actually just gets bigger. So that's how a volcano is formed. Let's look at the Ring of Fire. The Ring of Fire is this area, and if you notice, it's right around one of the tectonic plates. A ring of fire is an area where the most active volcanoes exist, and the ones that are the most violent also exist. The bottom of the screen, where you have the orange continents with the red outlines, those you can see are the different tectonic plates. And so we're talking about this area in the Pacific plate, right between the Eurasia plate, the Eurasian plate, and the North American plate. So this ring of fire is in between two tectonic plates that are moving, meaning that there's openings into the Earth's crust, and that is where the magma is able to come out. One of your assignments this week has to do with the ring of fire. You're going to read a little paragraph about it and then answer questions. So again, these are the areas where we have the most active volcanoes and the most deadly volcanoes. So these are different types of plate boundaries. These are from your book. There are 3 different types of plate boundaries. We have the divergent boundary, a convergent boundary, and a transform boundary. The divergent boundary is the area where plates move apart, away from each other. You can see that in the picture. A convergent boundary is where plates come together, push toward each other. And then a transform boundary is where plates slide past one another horizontally. So I know that this is in your video quiz, so make sure that you pause the video here and answer the questions that have to do with the boundary, because the answer is here on this screen. And then here I have a picture of the different boundaries moving together. So when you have a divergent boundary, it means that the two continental plates, like I said, they're spreading away from each other. A convergent boundary is where the plates run into each other. And if you notice with this one in the little diagram at the bottom, the left-hand plate, once they run into each other, actually slides beneath the one on the right-hand side. And then you have a transform boundary where they slide past one another. What causes earthquakes? Earthquakes happen when rocks that are inside Earth's crust suddenly rupture or break apart. This releases a massive amount of energy, and it travels through Earth's crust. This produces violent shaking on the crust. So again, when the rocks that are inside Earth's crust break apart or move suddenly, it causes a massive amount of energy to shake the crust. Now, why would the rocks suddenly break apart? Well, it has to do with the boundaries. If the plates that are that are beneath us move, it can cause the rocks that are on top of them, of course, to move violently. This chart is explaining the Richter scale. This is the typical way that we measure, just a second, sugar. Sorry, my dog. This is the typical way that we measure the strength of a volcano, or an earthquake. You might hear people say, oh, that we had a 5 magnitude earthquake today. And what they're talking about here is the Richter scale. So here's kind of a chart on, what each of the different magnitudes mean. If it's a 0 to 2, it's not usually felt by people. It's just something that we know can happen based on the machines that we have that measure earthquakes. They can tell. And then 2 to 3 is felt by a few people, but not very often or very many. A 3 to 4, you can see maybe the ceiling lights start to move around. Maybe you can see like a little bit of movement. When I lived in Oklahoma, we had several earthquakes there. And I had a pool at my house, my parents' house, and you could sort of see it had been really still, and you could see the pool water kind of gently rocking back and forth like it was a bathtub. 4 to 5 is going to be walls start to crack. In a 5 or a 6, the furniture is going to be moving. You might have lamps fall over. You might have pictures fall off the wall, or if you have a shelf, the things might fall off of the shelf. If a 6 to 7, some buildings are going to collapse. In a 7 to 8, a lot of them are going to be destroyed. And then if it's an 8 and up, that's a really, really severe earthquake. And you're going to have a total destruction of buildings, bridges, and roads, and you're going to see loss of life. We're going to watch a video about earthquakes. Oopsie.
The ground starts to quiver. Glasses rattle.
The ground
Soon
starts
walls
to quiver.
shift and everything
Glasses
begins to
rattle.
collapse.
Soon
Telltale
walls
signs
shift
of what
and
could be
everything
a
begins to
devastating
collapse.
earthquake.
Telltale
We've
signs
seen
of
the
what could be
destruction.
a devastating
While we
earthquake.
may think
We've seen the destruction.
we've seen the destruction
Well,
they
we may
unleash.
think we're
Some of us may have even
We've
lived through
seen the
one.
destruction
And
they
we know
unleash.
they can be
Some of
deadly.
us may have even
But
lived
where
through
does
one.
this mountain moving
And we
force
know
come
they can
from?
be deadly. But where does this
While we
mountain
may
moving
think we're
force come
standing
from?
on solid ground, the earth beneath us
Well, we
isn't
may think
completely
we're standing
stable
on
at all.
solid ground. The
Our
earth
planet's
beneath us
crust
isn't
is made up
completely
of
stable
about
at all.
12 major tectonic
Our
plates
planet's
that
crust
fit
is
together
made up
like a
of
giant
about
jigsaw
12
puzzle.
major tectonic
These
plates
huge
that fit
slabs of
together
land
like a
float
giant
on
jigsaw puzzle.
superheated magma
These
and
huge
constantly
slabs
shift,
of land
bump,
float
and
on
grind against
superheated
one another.
magma and
It's
constantly
there,
shift,
along the
bump, and
seams,
grind
where
against one
earthquakes tend to
another.
happen.
It's there,
When
along the
friction
seams,
between the
where
two
earthquakes
plates is
tend to
violent
happen.
enough, seismic
When friction
shockwaves
between the
ripple
two
through
plates
ground,
is violent
rattling
enough,
everything that
seismic
stands on it.
shockwaves ripple through the
stronger
ground,
and
rattling
shallower the quake,
everything that
the
stands
more
on it.
violent the destruction.
The stronger and shallower
The
the
most
quake,
violent
the
type
more
of earthquake
violent
is
the
born
destruction.
in a subduction zone.
The most
where one
violent type of
tectonic plate
earthquake
is
is
shoved
born
beneath
in a
another.
subduction zone,
While
where one
plate is
tectonic
forced
plate is
downward
shoved
into the
beneath
mantle,
another.
the other jets
While one
upward,
plate is
often
forced
violently.
downward into the mantle,
This
the
is
other
the type
jets
of quake that
upward,
rocked
often
Nepal in
violently.
May 2015.
This is the type of quake that rocked Nepal in May 2015.
And when subduction happens under the ocean, it can create giant
And when subduction
unstoppable
happens
waves
under
called
the ocean,
tsunamis,
it can
like the
create
ones that
giant,
killed hundreds of
unstoppable
thousands
waves
in
called
Japan and
tsunamis,
Indonesia.
like the ones that killed hundreds of thousands in Japan and Indonesia.
On average, earthquakes kill about 10,000
On
people
average,
each year.
earthquakes kill
Sometimes
about
numbers are far
10,000
higher.
people each year.
The quake that hit
Sometimes
Haiti in
numbers are far
2010
higher.
killed more than
The quake that hit
300,000
Haiti
by
in
some
2010
making it
killed
one of the
more than
deadliest on record.
300,000 by some counts, making it one of the
It is
deadliest on
estimated
record.
that there are 500,000 detectable
It
earthquakes
is estimated
in the
that
world
there are
each year.
500,000 detectable
100,000 of these
earthquakes
can
in
be
the
felt,
world
and
each year.
100 of them cause
100,000 of these
That's
can be
about
felt,
0.1%.
and 100 of them cause damage.
The magnitude
That's
of an
about
earthquake is measured using
0.1%.
the Richter scale, which
The
runs
magnitude
from 0
of an
to 10,
earthquake is
10
measured
being
using the Richter
strongest.
scale, which runs from
Every
0
whole
to
number
10,
increase on
10
the
being the
scale means
strongest.
10 times
Every
more ground
whole
motion
number
change.
increase on the scale means
In
10
recorded
times
history,
more ground
the world
motion
has
change.
never experienced a 10
In
on the
recorded
Richter scale,
history,
but
the world has
scientists predict
never
an average
experienced
of
a
at
10 on the
least
Richter
one
scale,
major quake
but
of
scientists
magnitude
predict an
8 or
average of at
higher
least
every
one major
year.
quake of
The
magnitude
fact
8
is,
or
the Earth's
higher
crust is
every
restless
year.
and
The
always on
fact
the
is,
move.
the
We
Earth's
can't
crust
see
is
earthquakes
restless
coming,
and
but
always
we
on the
can
move.
prepare for them.
We can't see
Engineers
earthquakes
are now
coming,
designing
but we
stronger
can
buildings,
prepare for them.
resilient enough to
Engineers
survive
are
a
now
direct
designing
hit.
stronger buildings,
Scientists are
resilient
crunching
enough to
data
survive a
project the
direct
power
hit.
of future quakes and
Scientists are
anticipate
crunching
when
data
and
to
where they
project
can
the
strike
power of
next.
future quakes and anticipate
Right
when
now,
and
we
where
can
they could
only
strike
estimate
next.
the probability an earthquake will
Right
occur.
now, we
But
can only
perhaps one
estimate
day
the probability
we will
an
learn to
earthquake will
predict
occur.
them,
But
minimizing
perhaps
their
one day
destruction
we
and
will
saving
learn to
countless
predict them,
lives.
minimizing their destruction and saving countless lives.
All right, I'm not sure why that one wouldn't go full screen, so sorry about that. Okay, so we saw lots of pictures there of earthquakes, how destructive they are, what happens when you're in them in terms of destruction and lives lost. So definitely some very serious things. I don't know if any of you guys have ever experienced earthquakes here in North Carolina. They happen a lot, like in California. They actually started happening a lot when I lived in Oklahoma because they do a lot of drilling there for oil. And some of the theories are that because they're drilling so deep down into Earth's surface to get oil, that it is affecting the plates that are beneath Oklahoma's surface and it's causing earthquakes. So probably when I lived there, I felt 3, and I lived there for like 7 years maybe. So interesting stuff that happened. None of the ones I was in were ever really bad. It was more like they were a 2 or a 3, I would say. But California, they get some pretty bad ones occasionally. So let's talk about all of this in relation to the Bible, because it definitely has a role to play. So it says, scientists do not fully understand what causes plates to move, but there is evidence that suggests a dramatic continental movement that happened in the past. So for example, what we're talking about is if we have a continent like Pangaea, if that's how God originally created the earth, the Bible of course doesn't tell us, It also doesn't prove that it's not true, so it could very well be the case. But if it was the case, then what would cause a supercontinent like Pangaea to break up? If we think about the flood, it says the Bible describes dramatic events that are associated with the flood. In Genesis 7:11, we have saying that all the fountains of the great deep burst open. So that could be talking about the earth's crust shaking violently and, of course, moving these continents to where they are now. It is possible that the events of the flood are the cause for these theories about plate tectonics and the location of the continents today. Currently, continental plates move very, very slowly. They only move about 1 to 4 centimeters per year, so that's like around an inch. At this rate, it would have taken millions of years for the continents to go to their current location. So obviously, we don't believe as Christians that the earth is millions of years old. We believe that it's much younger than that. So we could maybe think that the flood or something like that caused these continents to move to their present location if, in fact, Pangaea did exist. So it says the violent events of the flood could have caused them to move much faster. And then, of course, we can, think about when we get to go to heaven, that's when we can ask God and we'll get to find out all of these different theories in science. What's true? How did it really happen? And we'll get to hear it from the source. So I have 2 more videos to show you. These are some pictures. These are real pictures. These are not fake. Post-earthquake of what can happen to roads and some structures when they are faced with some intense movement. So let's watch this one first. Hopefully it'll go full screen.
Portals into the heart of the earth. They burn.
Portals into the heart of the earth. They burn. Bottomless cauldrons fueled by an ancient wrath, bubbling and boiling thousands of miles beneath the surface and just waiting to burst through.
Volcanoes are scattered across the planet.
Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor.
So this area here is the Ring of Fire, where it says the word countless. That is the Ring of Fire. So it's between the western coast of North America and the eastern coast of Asia.
Most volcanoes, whether on land or underwater,
are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes.
There are several types of volcanoes,
primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains, shield volcanoes, which are flatter and dome-shaped, calderas, which are large depressions in the ground, and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions.
Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists develop the Volcanic Explosivity Index, or VEI. It considers various factors such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera. While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible. Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.
Next video.
Enjoy this movie, then visit brainpop.com for much more. Enjoy this movie, then visit brainpop.com for much more. Are you sure this?
All right, I'm gonna try that one again.
Enjoy this movie, then visit brainpop.com for much more. Enjoy this movie, then visit brainpop.com for much more. Are you sure this thing is rated for this depth? Are you sure this thing is rated for this depth? You bought it from an Air Mall catalog. Oh, great. You bought it from an Air Mall catalog. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. When I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. Some continents look exactly like puzzle pieces that snap together. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. A scientist named Alfred Wegener. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. Wegener couldn't explain why Pangaea split up or how. His idea. But there was some evidence to support his idea. Had been found oceans apart. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Provided an explanation. Wegener's theory of continental drift provided an explanation. Long after he died. But his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the mid-Atlantic ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. At the ridge and spreading new seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. There's a lot going on beneath the Earth's surface. As he suspected, there's a lot going on beneath the Earth's surface. Pretty cool and stable. Up here, everything seems pretty cool and stable. It's a raging inferno. But miles below our feet, it's a raging inferno. Earth's center, the deeper you go, the hotter it gets. As the surface of the sun. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. Well, the lithosphere
pieces,
isn't like a
each one
smooth
different
shell.
Shape, size,
It's
and
cracked into
thickness.
pieces, each
We
one a
call
different
those
shape,
pieces
size,
plates.
and thickness.
Yep,
We call those
the
pieces
Mid-Atlantic Ridge
plates.
is a border between several plates.
Yep, the Mid-Atlantic
They're being dragged
Ridge is the
apart by
border
forces
between
from
several
deep inside
plates.
the planet.
They're being dragged apart by
You can think of
forces
it
from
like a
deep
pot of
inside
soup.
the planet.
The Earth's
You can
core
think
is
of
the
it like a
burner,
pot of
and the
soup.
mantle is the boiling soup.
The Earth's core is
As
the
the soup
burner,
near
and the
the burner
mantle is the
heats up,
boiling
it
soup.
becomes less dense
As the
and
soup
rises.
near the burner heats
When it
up,
gets to
it
the
becomes
top, it
less
cools
dense
off
and
sinks
rises.
down toward the heat.
When it gets to the top,
In
it
physics,
cools
those are
off
called
and sinks
convection
down toward the
currents.
heat. In
A
physics,
similar
those are
process
called
is driving the
convection
mantle,
currents.
and it's taking the plates along
A
for the
similar
ride.
process is driving the
movement
mantle, and
is
it's
called
taking the
plate
plates along for the
tectonics.
ride. That movement is called plate
It's the engine
tectonics.
driving the constant transformation of our planet's surface.
It's the engine driving the constant
Plates have been
transformation of our
bouncing off
planet's
each other
surface.
For eons. The oceans
Plates
have
have been
expanded
bouncing
and
off each other
contracted.
for eons.
Land masses
The oceans have
smashed
expanded
into each other
and contracted.
broken apart.
Land masses have smashed into each other and
The
broken
plates
apart.
move about as fast as your fingernails grow. So
The
we
plates
don't see
move
the
about as
ground
fast
sliding
as your
around under our
fingernails
feet.
grow.
But
So
do
we don't
sometimes
see the
feel it.
ground sliding around under our feet.
Yep,
but we do
I'm
sometimes
talking about
feel it.
earthquakes. Seismic activity
Yep,
is
I'm
greatest
talking about
along plate
earthquakes.
borders.
Seismic activity is
At
greatest
convergent
along
boundaries
plate
where
borders.
two plates collide. At
At
divergent
convergent boundaries where
they
two
pull
plates
apart.
collide.
And at
At
transform
divergent boundaries where they pull
slide
apart.
past each other.
And at transform
At all three
boundaries where they
boundaries,
slide
there's
past
enormous
each other.
pressure on the Earth's crust.
At all three boundaries,
That's the
there's
topmost
enormous
layer of the
pressure on the
lithosphere.
Earth's crust.
The pressure
That's
can
the
build
topmost
up
layer
for
of the
years.
lithosphere.
The longer it takes
Pressure
to
can
release,
build up
the
for
bigger the
years.
earthquake.
The longer it takes to release, the
Yep,
bigger the
and
earthquake.
Plate movement drives volcanic activity too.
Yep, and plate
At
movement
divergent
drives volcanic
boundaries, like the
activity
Mid-Atlantic
too.
Ridge, there's a gap in
At
the
divergent
lithosphere.
boundaries like the Mid-Atlantic
So
Ridge,
magma,
there's a
molten
gap
rock
in
from
the
the mantle,
lithosphere.
is constantly pushing
So
up along the
magma,
boundaries.
molten rock from the mantle,
These
is
are the most
constantly
volcanically
pushing up
active
along the
places on
boundaries.
Earth.
These are the most
Volcanoes
volcanically
are also
active
common
places
at
on
boundaries
Earth.
called subduction zones.
Volcanoes are
That's
also
when a
common
dense
at boundaries
ocean
called
plate
subduction
converges with
zones.
a lighter continental
That's when a
plate.
dense
The
ocean
heavier
plate
gets
converges
pushed
with a
below,
lighter
down into the
continental
mantle.
plate. The heavier
Some
plate
of it
gets
melts,
pushed
and the
below,
magma
down into the
erupts
mantle.
farther inland.
Some of it melts, and the
The
magma
ring of
erupts
fire
farther
is
inland.
a massive chain of these volcanoes.
The ring of
Dense
fire
sedimentary
is a massive
rock making
chain
up
of
the
these
Pacific
volcanoes.
seafloor is subducted,
Dense sedimentary rock making up the
transformed into
Pacific
metamorphic
seafloor
rock
is
through pressure and
subducted,
heat,
transformed
and then
into
recycled
metamorphic
as
rock
igneous
through pressure
rock
and
through
heat,
volcanic eruptions.
and then recycled
In other words,
as igneous
plate
rock through
tectonics
volcanic
drives
eruptions.
the rock cycle. The
In other
constant
words,
process of
plate tectonics
transformation and
drives the
renewal
rock
of
cycle,
Earth's
the
crust.
constant process of transformation
It
and
also
renewal
creates our
of the
most
Earth's
prominent
crust.
geologic features, mountain ranges.
It also creates our most prominent geologic
that happens
features,
when two
mountain ranges.
continental plates converge.
That happens when two continental
Since they're
plates
both about the same
converge.
density, neither one subducts.
Since they're both about the
Instead,
same
it's
density,
like a slow
neither
motion
one
car
subducts.
crash. The plates
Instead,
buckle
it's
and
like a
warp.
slow motion car
land
crash.
pushes
The
up into
plates
jagged
buckle
peaks.
and warp. The
The
land
Himalayas are
pushes up
still
into
growing
jagged
from a plate
peaks.
collision that began
The
half
Himalayas
a
are
billion
still
years
growing
ago.
from a plate collision that began half a billion
yeah,
years
Alfred
ago.
Wegener's theory has come a long way in 100 years.
Yeah, Alfred
He was
Wegener's theory has come a
practically
long
laughed
way
out
in
of the
100
scientific
years.
community for his ideas.
He was practically
today,
laughed
plate
out of the scientific
tectonics is the
community for his
unifying
ideas.
theory that
But
ties
today,
together the
plate
entire
tectonics is
field
the
of
unifying
geology.
theory that ties together the entire field of geology.
What do you mean, out of juice? We're stuck here?
What do you mean, out of juice?
Now what?
We're stuck here? Now what?
Oh, thank you.
Oh, thank you.
Visit us at brainpop.com.
Visit us at brainpop.com for
Okay, so that was the end of the presentation aspect of it. Hopefully you learned something from the slides and then from the various videos that you were shown. Now we're going to go over the homework. So this is saying that this assignment needs to be completed during or after you watch the video. So hopefully you guys got the memo from the front page of your assignments from this week when I attached it to the front of the packet. If you got the hard copy, and then if you got the digital one your parents printed, it was the very first page in it. So you need to answer these questions. Every single question comes straight from the presentation. So if you are missing one, then you need to go back and try to find the slide that was talking about it. None of it is from the video, although I'm sure some of it was repeated in a video, but all of this was stuff that was on the actual slides. So you may need to look at the slides, you may need to pause the slides, read what they say in order to get it correct. It says make sure to complete it fully in a neat handwriting, put your name on it, and then send it to me. This is your reading comprehension assignment actually this week. It goes along with what we talked about. You're going to read the article that is in the yellow, has the yellow arrow and the yellow border. You're going to read that passage about the Ring of Fire and then answer the 8 questions at the bottom. And then the one that has the blue border, the blue arrow, you're going to get a red and a blue coloring device, anything you want, pen, color pencil, crayon, whatever. You're going to color the red, the triangles red. Those represent the 10 largest recorded volcanoes. And then you're going to color the circles blue, and those represent the 10 largest recorded earthquakes. So not only does the Ring of Fire have to do with volcanoes, it also has to do with earthquakes. And then you're going to answer the 3 questions there at the bottom. Send a picture of it to me, and I will grade it. And then lastly, this is something we did last semester. We did the agamograph in art. You were able to draw whatever picture you wanted. If you recall, I did like a donut prior to eating it and then a donut after eating it. You're going to do the exact same thing today or this week, except you're going to do a volcano on picture template 1. You're going to draw a volcano before it erupts, so it's peaceful. And then picture 2, you can draw a volcano after it erupts, or I should say during its eruption. So you can either do it where the volcano is, the lava is falling down the sides of the volcano, or the lava is all the way up in the air still. If you don't want to do lava, you want to just do ash, you can do that as well. So you are going to draw that with pencil, and then you're going to color it neatly. Remember to cut out the pieces, and then remember you glue them neatly onto the correct spot on template 2. I could not attach template 2 to this document, but it is in your packet. And then you're going to remember to fold it in accordion style. If you need help remembering how to fold it in accordion style, you can either get on the Zoom call with me, or I'm sure if you go to YouTube and you just type in agamograph folding, I'm sure there's tons of videos up there that will show you how to fold that properly. All right. And then that is the end for science presentation, the science presentation. Again, make sure that you've completed your assignments. If you have any questions, you can ask me on the Zoom meeting from 9 to 12, Monday through Friday. And other than that, just make sure to send me pictures of your assignment when you are done, either through text or email, and I can get that graded for you. All right, guys, I miss you. Hope you guys have a great week, and I will see you at 9 a.m.